Hello, geometry students. I hope you are doing fantastic. We are getting ready to do, this is kind of confusing, but notes for 11.4b. Your current geometry book did not go into as much detail in section 11.4 as we normally would. They assumed that a lot of what you needed to know you already knew. And I just wanted to review a little bit more with you guys. So that's why I've made an 11.4 A, B, and C so that we can have the opportunity to make sure that we haven't missed anything. So we're going to talk about 3 surface area formulas today. The formula for the lateral area of a prism, for the surface area of a prism, and then the surface area of a cylinder. All 3 of these formulas are on your formula sheet for chapter 11, and you will have access to that formula sheet on any quiz or test in this unit. So basically what we are doing today is talking over what the parts of the formula mean and how to use those when you're actually doing the calculations. So let's go ahead and write down the formula for the lateral area of a prism. We're going to use a capital L, and we're going to say that that is equal to capital P times H. Now, capital P stands for perimeter of the base, and H stands for the height of the prism. Now, something that's really important to know when you're talking about a prism is what we mean by height is the distance between the 2 bases. The bases are whatever you have 2 of that are parallel to each other. So let's say, for example, that we are working with a hexagonal prism. So we know that it's a hexagonal prism because the base is a hexagon. And we would have 2 of those hexagons that are parallel to each other. So when we say height, we would mean this number right here. This would be the distance between the 2 bases. Now, unless it has been specified otherwise in this unit, when we have a base, such as this hexagon, we are going to assume that it is a regular hexagon. And what that means is all 6 sides are the same and all 6 angles are the same. So if I have one of the sides of my hexagon marked with a 5, like that, I can assume that the other ones are also of length 5. So I can put 5s on all of those. So if I wanted to find the lateral area of this figure, lateral area, by the way, basically it's a fancy way of saying the sides. So like, for example, if you were talking about a soup can, it would be the label of the soup can, but not the 2 ends. In this case, when we're talking about lateral area, we would mean all the rectangular sides, but not this base here or the other base on the back. So we're going to need capital P, which is perimeter. In this case, there's going to be 6 sides that are 5 units long. So our perimeter is going to be 30. So we're going to take 30 times 12, and we're going to get 360. And I think in the problem that I normally do with this is in centimeters. And you typically would write your answer in centimeters squared. So that would be an example of how we can use the formula for the lateral surface area of a prism. You do need to know the perimeter of the base, and then you need to know the height, which is the distance between the 2 bases. Now, most of the time when you're looking at surface area, you want the total surface area. So not just the sides, but also the 2 ends. So the formula for the total surface area of a prism is to take the lateral area and add 2 of the bases to it. Or if we want to be more specific, we know the lateral area is perimeter of the base times height. That's what we just learned. So you would do the same thing that we just did, but then add on the 2 bases. So let's do an example, and I'll draw a line here to block this off a little bit. Let's do an example of a triangular prism. And again, we know this is a triangular prism because we can see that the two bases are triangles. So the bases are triangles because they are the two sides that we have two of that are parallel to each other. So our base here, and sometimes I make a note of this, the base is a triangle. The sides would be rectangles, but the base would be a triangle. Now, in order to do this problem, I am going to need to know the capital B. So let's make a note of what this is. Capital B stands for area of the base. So I'm going to go ahead and give this figure some dimensions. Let's say that this length is 12 here. And we have a height of the triangle of 8. And then this length right here is 10. Now, to find the area of this triangle base, my formula is 1/2 base times height. The base of my triangle is 12 and the height is 8. Half of 12 is 6 and 6 times 8 is 48. So I know when I figure out my total surface area and I need to include the area of the base, I'm going to use 48. I can also see in looking at the formula here that I'm going to need the height of the prism. So the height of the prism. See if you can tell which number is the height. Height, remember, means the distance between the two bases. In this case, the bases are triangles. What number would the height be on this figure? If you said 10, you're correct. The height of this prism is 10 because it is the distance between the two bases. Now, to calculate the perimeter, because we're also going to need that in our formula, we need to know this distance all the way around. The key to doing this, again, is remembering what I said a minute ago, that all of our bases are going to be regular polygons. So this triangle right here is going to actually, you know what? I don't know if it is a regular polygon. Let me double check and see, because it's been specifically labeled with dimensions. I guess we have to actually check it out here. If this length is 12, then these two pieces are going to be 6. This is actually a 6, 8, 10 triangle right here, and the other side would be the same. So this case, it really should, you want to note that since the more than one piece of information has been labeled about the base, that you do need to double check and see whether it's regular or not. That's not a regular triangle because the three sides of the triangle are not the same. But we can still find the missing information here by doing Python. This is a 3, 4, 5 triangle multiplied by 2. So the perimeter is going to be 10 plus 10 plus 12, which would be 32. So now I have all of the information I need for my formula. The surface area is going to be my perimeter of the base, which is 32, times 10, which is my height, plus 2 times the area of the base, which is 48. If I do that on my calculator, I have 320 plus 96, or 416, and then units squared, whatever our units would be. So those would be the steps that you would use to find all the parts of that missing formula. Okay, the last formula that we're looking at on the notes today was the surface area of a cylinder. So we're going to write the formula here. It's going to be the same formula as we used for the prism, but because a cylinder always has bases that are circles, we are going to be able to be a little bit more specific. So for my lateral area, normally I would say perimeter of the base times height. But in the case of a cylinder, and let's draw a circle of that here, or a picture of it here, the perimeter is actually circumference, or 2 pi r. So when I want to take perimeter times height, it would be 2 pi r times height. plus 2 times, and again, since the base is a circle, our area for the circle is always going to be pi r squared. So with a cylinder, we have a little bit more specific information. All right, the radius of this cylinder I'm going to label as 14, and the height I'm going to label as 18. This is a lot more straightforward, I think, than the other two. We literally just plug in 14 for R and 18 for H. The only kind of trick to make sure of here is that you do need to do PEMDAS. Let me make it a little bit better pie there. You do need to do PEMDAS. So on the second piece, let's do this one first. I'm going to take 2 times 14 times 18, and that's going to give me 504 pi for the first piece. For the second one, I want to square 14 and then multiply that by 2, because we have to do exponents first. And this is going to be 392 pi. If I add those together, that's 896 pi. Or if I want to turn it into a decimal using the pi button on my calculator, it would be 2,814.9. So those are examples for each of the surface area formulas for 14b. Thanks, guys.